Batteries. Batteries. What is a battery? A battery is a device that contains one or more electrochemical cells. Batteries store energy in chemical form and, when required, convert that chemical energy into electrical energy. Batteries are connected to electrical devices such as remotes, flashlights, etc. There are many different types of batteries for different uses. They all have advantages and disadvantages. I will be talking about some different types of batteries and how they work. The batteries that I will be covering are lead acid, nickel cadmium, nickel metal hydride, alkaline, and lithium. I will also be talking about the future of batteries and how they can be improved. Before that, let's go over how batteries work. Batteries store energy and when used, turn that chemical energy into electrical energy. Electricity is the flow of electrons through a conductive path in a circuit. Three main parts are involved in the operation of a battery: the anode, which is negative, the cathode, which is positive, and the electrolyte. The reactions within a battery are different among different types of batteries. However, the general way in which a battery works is as follows. The chemical reactions within a battery produce an excess of electrons at the anode. These electrons want to move to the cathode, but the electrolyte stops this from occurring. For the electrons to move to the cathode, the circuit needs to be completed. This is typically done by inserting the battery into something, for example, a flashlight. Once this is done, the electrons will move through the flashlight to the cathode, lighting the flashlight up in the process. This process, however, changes the chemicals in the battery so it is no longer able to produce as much power. This is why batteries have limited power. Lead acid. The first type of battery that I will cover is lead acid. These batteries were invented by Gaston Planté in 1859. The main application of these batteries is in cars. In cars, their function is to provide a burst of power so that the engine can start up. As the name suggests, these batteries have both lead and acid in them. The anode is made of lead. The cathode is made of lead dioxide. The electrolyte is sulfuric acid. A surplus of electrons gathers at the lead anode. This happens due to the reaction of lead with bisulfate from the sulfuric acid. These surplus electrons then move to the cathode via the vehicle wiring, powering the car in the process. The alternator, a generator attached to the engine, reverses this reaction during engine operation, recharging the battery. Advantages include low cost, reliability, robustness, wide range of sizes and capacities, many suppliers, recyclable. Its disadvantages are it's heavy and bulky, slow charging, can overheat, and short life. Nickel cadmium. Nickel cadmium batteries are the next type I will cover. These rechargeable batteries have been around since 1899. They were invented by Waldemar Jungner of Sweden. These were the first rechargeable batteries used in power tools, lights, mobile phones, and other portable devices. Their anode is made from cadmium. The cathode is nickel oxide hydroxide. These batteries were at one point very common in portable devices, but have since been replaced with nickel metal hydride and lithium-ion batteries. Its advantages are: it is cheap, powerful, robust, reliable, and fast charging. It has its disadvantages as well. It was prone to not recharging to full capacity. It died if it was left unused. However, the main reason these batteries were somewhat phased out was because it used materials toxic to the environment. Nickel metal hydride. The problems with the nickel cadmium batteries ultimately led to the start of the development of nickel metal hydride batteries in 1967 at the Battle Geneva Research Center. They were first available for consumer purchase in 1989. Like nickel cadmium, it uses a nickel oxide hydroxide cathode. The anode, instead of cadmium, uses a hydrogen absorbing alloy. A variety of compounds have been developed for use as the anode. Some examples are lanthanum, cerium, neodymium or praseodymium, mixed with nickel, cobalt, manganese, or aluminium. Advantages include high capacity, high energy density, safe for the environment. Disadvantages are short lifespan, expensive, and high maintenance. Alkaline. These are the most common types of batteries. They have a wide variety of uses, mainly in household items such as toys, electronics, remotes, and lights. Batteries with an alkaline electrolyte were invented by Waldemar Jungner in 1899, and then independently by Thomas Edison in 1901. The modern alkaline battery using zinc and manganese was developed by Canadian engineer Louis Urey in the 1950s. Zinc is the anode. Manganese is the cathode. The name comes from the electrolyte, which is alkaline. These batteries have become the battery of choice for consumer electronics due to their many advantages. These advantages are high capacity, high performance in low temperature, long shelf life, durability, some are rechargeable, safe, reliable, versatile, and easy to come by. Its few disadvantages are it is bulkier and heavier than lithium, it can leak, and it has low power output. These batteries are the most produced, widely used, and easy to dispose of. They also have a variety of sizes, so they can fit in many different devices. The main way in which these batteries can be improved is to improve the recycling of them. Lithium. American physicist Professor John Goodenough created the lithium battery in 1980. Nowadays, lithium batteries play a very important part in our everyday lives. They are the batteries used in our phones, computers, cameras, and many other portable consumer electronics. Lithium batteries are small and can be credited for the slimmer electronic devices we have today. They are also used in remote control devices like planes and cars, and medical devices that need to last a long time. Lithium batteries have a lithium anode, hence the name. They have an incredibly wide variety of cathodes and electrolytes. Lithium batteries are said to be the battery of the future because of their many advantages. Long-lasting, small and light, versatile, long shelf life, long lifespan, fast charging. Disadvantages are reliability, price, and safety. These batteries can catch fire if improperly used or charged. It is important to remember that these batteries are newer and are still developing. Over the next few years, they will improve a lot. The future of batteries. When it comes to improving batteries, the main goals are to make them more powerful, last longer, charge faster, be safer, more environmentally friendly, smaller, and lighter. Gold nanowire batteries are being developed that have an incredibly long lifespan. Graphene batteries are also being developed to make faster charging and more powerful batteries. To improve versatility, companies are working on batteries that are flexible. Another future improvement to battery versatility is wireless charging and over-the-air charging. To improve better safety, people are developing fireproof batteries. Overall, the future of batteries looks very positive. Thanks for watching.